Hi students, in today's class I am going to explain about gunshot models from chemical equilibrium. If you watch this video, definitely you will get at least one question from this video, or same question or maybe same model definitely you will get for JEE mains session 2 or maybe NEET or maybe MCET. So that don't miss this chance and also try to watch complete video and try to apply all these models what I have mentioned in this video. So I am going to start today's class. Dear students, here in this question you need to calculate Kc for this reaction by observing these two reactions. In the first reaction, ammonia reacting with Az plus, then it will become AzNH3 plus. Here the K1 value is 1.6 into 10 cube. Okay. So then the second equation is AzNH3. That means the formed AzNH3 plus here reacting with one more NH3 plus. Here I am going to write that one more NH3 plus. So then it would become AzNH3 twice plus. Here also K2 value is there 6.8 into 10 power 3. Okay. So then equilibrium constant for the following reaction you need to calculate. Here if you observe about two reactions, from these two reactions you will get the third reaction. How will you get that reaction? See here, this one and this one cancel out. So this Az plus, see this one and this one and this one 2NH3, then it will gives you this. So the AzNH3 and this AzNH3 would become cancelled out. Here if we add two chemical reaction in chemical equilibrium, so you need to understand that Kc becomes, that means the equilibrium constants for those two reactions are going to be multiply. So here I am going to do that. Kc equal to, this is the resultant equation, just remember, by adding these two reactions. Okay, so then Kc equal to K1 into K2. What is the K1 value? K1 value is 1.6 into 10 power 3 and K2 value is 6.8 into 10 power 3. So you can take 1.6 into 6.8 into 10 power 6 like this. Say 3 plus 3. Okay, if you multiply 1.6 into 6.8, then you will get 10.88 into 10 power 6. So I want to reduce this decimal, I want to move this decimal left side. So then I will multiply with 10 and divide with 10. So then I will get 1.088 into 10 power 7. This is the equilibrium constant for the resultant equation. This is one of the most important question mentioned in previous year papers. In this question, a vessel contains carbon dioxide gas at the initial pressure is 0.5 atm. The temperature is 1000 Kelvin. After some time, if you add graphite, that means carbon in the form of graphite, to that vessel, then carbon dioxide gas converted into carbon monoxide gas. At that time, the equilibrium pressure is 0.8 atm. The initial pressure is 0.5 atm. Then we need to calculate about what is Kp value. Okay, so you need to frame one equation to this. CO2 gas reacting with carbon in the form of graphite. Then they will form 2 moles of CO gas. Okay, this is the balanced equation. So here it's already mentioned initial pressure is 0.5. So that is 0.5 you can write. At initial stage the pressure of CO is 0. So then after some time this would become That means sum of CO2 converted into CO. That some amount we don't know. That's what, just imagine. Some X amount going to be converted into CO. So that is X. Here 2 moles is there. So then you can multiply with 2. So here it's already mentioned 0.8 atm in the data. So that you can take sum of pressure. See here, initial pressure, pressure of CO2 at equilibrium and pressure of CO at equilibrium. So 0.5 minus x plus 2x equal to 0.8. That means this is total pressure at equilibrium mentioned in the data, and this is the total pressure from the equation. Okay, so then you will get here, by solving this equation, you will get x equal to, here see, that means 0.5 plus x equal to 0.8 you will get. So then here you will get x value equal to 0.8 minus 0.5. So that here this would become 0.3 atm. So then you can substitute this x value here in this one. So then you will get 0.5 minus 0.3. So it would become 0.2. That means the pressure of CO2 at equilibrium will be 0.2. Then here if you substitute 2 into 0.3, it would become 0.6. That means the pressure of carbon monoxide at equilibrium is 0.6. So then you have pressure, pressure at equilibrium for CO2 and CO. Then you can go to calculate about Kp value at equilibrium. Kp equal to product's concentration, that is here CO power 2, here 2 moles, and then reactants concentration CO2 power 1. So then here you can substitute the pressure of CO and the pressure of CO2. So 0.6 into 0.6 upon 0.2. So then Kp equal to 1.8 atm. This is the answer to this question. This is one of the most important question mentioned in previous year papers. Okay. In this question we have given weight for N2, H2 and ammonia. Given weight for N2 is 28 grams, given weight for H2 is 6 grams and ammonia is 17 grams. So by using this data you can identify about their number of moles. So here number of moles for N2 equal to 28 upon 28, because its molecular mass also 28, so it would become 1. And then after number of moles for H2 equal to 6 upon 3, this would become 2. Not 3, it is 2 because molecular mass is 2, so this would become 3. So then after number of moles for ammonia NH3 equal to 17 upon 17, its mass, its molecular mass would become 17. So this is also 1. So then after you can write chemical equation for this problem, balanced equation, that is N2 gas plus H2 gas is reversible, then it will become NH3 gas. So you can balance this 2 moles of NH3. So here how many moles? This is 1 mole, this is 3 mole, this is a 2 mole. So here is there any other information here? 1 liter vessel is there. So here suppose here it is 28 grams of N2 and 6 grams of H2, 17 grams. So if I mean that means if X amount is going to be out in the form of NH3, so then this would become 1 minus X, then this would become 3 minus 3X, and this is the 2X. Okay, so this is the pressure at equilibrium. So you can take this 1 liter, equalize this 1 liter to the 2x, because ammonia at present in 1 liter vessel, so number of moles equal to 1 liter. So then you will get x equal to 0.5. Then substitute here 1 minus 0.5, 3 minus 3 into 0.5, 2 into 0.5, 0.5, 1 minus 0 point becomes a 0.5, 3 minus 1.5, this is 1.0. So at equilibrium N2 pressure is 0.5, this would become 1.5 and this would become 1. So then you can go to calculate Kc value here. So Kc equal to products concentration, ammonia concentration power 2 upon N2 concentration power 1 upon H2 concentration power 3. Here see these values I am going to take. Okay, so then you can substitute NH3 concentration is 1 upon, here see N2 concentration is 0.5 into 1.5 is the H2 concentration power 3. Then you need to simplify. If you simplify this one, 1 by if you calculate this one, 1.6875. So then after, if you simplify some more, after that it will gives you 0.6 is your answer. This is the nearest value. This is also one of the most important question that was mentioned in previous year exams. Okay, so here in this data given weight for N2O5 is there and volume is there, R value is there, and is there anything? Yes, temperature also there. So that here you need to calculate first initial pressure by using the given data. Here I am going to calculate that initial P equal to nRT by V. You can use this formula. So here P equal to N number of moles for N2O5 you can take. So that given weight upon molecular weight, number of moles, molecular weight of N2O5 is here you can take 108. If you calculate N2 weight is 28 into 2, okay, plus 5 into 16. If you do like that, you will get this one only, okay, into R value here already mentioned 0.082. So then temperature is here 500 Kelvin upon volume is 1 liter. So if you calculate this one, you will get 14.35 bar pressure. Okay, so then you need to go to the chemical equation now. So here I am going to write it again, this chemical equation. 2N2O5 gas converted into 2 moles of N2O4 gas plus O2 gas. Okay, so here here what you have calculated previous, that is 14.35, you can consider that is the initial pressure of N2O5. 14.35 is the initial pressure. So here this is 0 and this is also 0. So then after some pressure is going to be converted into N2O5 and O2. So that pressure is, imagine, P. So here P becomes 2P because here 2 moles is there. So that here this is a 2P. Then here it would become 2P and this is the 1P. So, and one more data is there in the, one more information is there in the given data, that is 18.65. So that means total pressure at equilibrium is 18.65. So that here you can add all these values 14.35 minus 2p plus 2p plus p equal to this one 18.65. okay, so then you will get 14.35 minus, say this one plus, okay, equal to 18.65. so p equal to 18.65 minus 14.35, then you will get p equal to, say this one 0, 6 minus 3, 14, 18 minus 14, that is 4. That means pressure at equilibrium is equilibrium P equal to 4.30. So then you can substitute this value, this P value here, see, in all these conditions. okay, then you will get pressure of N2O5 at equilibrium, pressure of N2O4 at equilibrium, and also pressure of O2 at equilibrium. So that's what, to calculate this one, I am going to rub this side. So by taking this P value, you can calculate individual pressures of N2O5, N2O4 and O2 at equilibrium. So equilibrium pressure for N2O5 equal to 14.35 minus 2 into 4.3. 14.35 minus, see this, 8.6. so that how much is this? 5 minus, suppose is there nothing is there here, just imagine 0, this is 5, 13 minus 6, 7, 13 minus 8, 5.7 is the pressure of N2O5. Next one, pressure of N2O4 you can take, that is what, 2 into 4.30. okay, so 2 3s are 6, 8.6. okay, 8.6 bar. Next, pressure of O2 equal to, as it is, 4.30. So then you need to go to calculate Kp value. Here to that I am going to rub this. So you can take Kp equal to products concentration N2O4 power 2 O2 concentration upon N2O5 concentration power 2. So then you can substitute all these values in this equation. Kp equal to N2O4 value is 8.6, 2 times you can write because that is power 2, and 4.30 upon, here N2O5 value you can write, that is also in 2 times, 5.75 into 5.75. So you need to simplify this all these values, then you will get, that is 961.8. Kp equal to 961.8. if you simplify, later on you will simplify because lack of space. okay, so but he is asking about nearest integer value, so that here multiply with 100 and divide with 100, then you will get Kp equal to 9.618 into 10 power minus 2. This is your answer to this question. This is also most important question mentioned in previous year exams. This is also one of the most important question and the simplest one. Here equation I need to write it here, but to save some space I just write it here only. okay, so the equilibrium constant Kp for the reaction is 4.0 atm. That means Kp value you have. You need to identify pressure of O2 at equilibrium. Here one condition was mentioned, that is at equilibrium partial pressures of SO2 and SO3 would become same. So then you try to take Kp value, Kp equal to pressure of SO3 products concentration power 2 upon pressure of SO2 reactants concentration, here power 2 because this is 2 and there is also 2, and oxygen concentration. This is equal to the 4.0 atm inverse. Okay, so here the condition was mentioned at equilibrium partial pressure of SO2 and SO3 would become same. So you just ignore these two, this one and this one, you just ignore. Kp equal to 1 by pressure of O2, I mean pressure of O2. So this is equal to the 4.0. So then I need to calculate only O2 value, pressure of P of O2. That means 1 by 4. 1 by 4 means P of O2 equal to pressure of O2 at equilibrium equal to 0.25 atm inverse. This is your answer for this question, and simplest one. This was also mentioned in your previous examination. In this question, for the reaction, for the given reaction H2 plus I2 becomes 2HI, attainment of equilibrium is predicted correctly by which one of these graphs? You need to identify. That means here, listen, the graph should be represent about decrease in reactants concentration and increase in products concentration. That was mentioned clearly in the third option. See, here this is time t and this is concentration. See, reactant hydrogen concentration decrease and it will at equilibrium it is going to be continue. I mean fixed value, constant. Okay, here also see H2 concentration decreases and then it is going to be fixed, and then also HI value. So, first it is increase and then after it is going to be equalize with the H2 and I2 concentration. Okay, so that this is the answer for this question.